All right, so I did chapter 4, question 25, which says a 55 kilogram ice skater is gliding along at 3.5 meters per second. 5 seconds later, her speed has dropped to 2.9 meters per second. What is the magnitude of the kinetic friction between her skates and the ice? Okay, so to start off, what we want to know is the magnitude of the kinetic friction. So there is an equation for this. It's just, F net equals the mass times the acceleration. And F net is actually the same as kinetic friction because the kinetic friction is the force, it's the only force causing the skater to accelerate to the left or slow down. And there's a little free body diagram kind of displaying that. The normal force and the force of gravity, they cancel out, and then we just are left with this kinetic force. So how are we going to solve this? Well, we have some variables already. We know the initial velocity is 3.5 meters per second. We know the final velocity is 2.9 meters per second. We know the change in time is 5 seconds, and we know the skater's mass is 55 kilograms. So we need to find acceleration if we're going to do this equation. How do we do that? Well, we have an equation. Acceleration equals the final velocity minus the initial velocity over the change in time. And like I said, we already have all of those variables. So from there, we just kind of plug and chug. So 2.9 meters per second minus 3.5 meters per second over 5 seconds. Do the intermediary step there, but ultimately it's going to give us negative 0.12 meters per second squared, and that is our acceleration. So now we have everything we need to do F net equals mass times acceleration. We have our mass of 55 kilograms, our acceleration of 0.12 meters per second, and I just did the absolute value of that. And we multiply those two together to get 6.6 newtons. So the magnitude of the kinetic friction is 6.6 newtons. Thank you.